hope my voice is clear for you, right? Okay. Yes. Let us see now we'll be discussing about the most important topic in DSA, binary search, right? So I think you might have knew about the binary search, and also I'll be explaining about the binary search, however. So today's topic is binary search. I'll explain the binary search algorithm, and then we'll go with some of the problems. Uh, if you have to share any thoughts or send me a hi for in the live chat, right? So we'll be starting with the binary search. Now, if I ask you that we are given with nums is equal to 1, 3, 5, 8, 7, 15, 20, 30, and the target is 135 wait a second 135 8 and then 9 and then 15 20 and then 30. If I ask you the target is 15, I need the index where target is present. I need to know this where target is present in the given array, right? So we might go with the linear search, but let me tell you how can we go with lesser logarithmic time complexity. Now, what I'll do is I'll go with 1. Check whether 1 is equal to target. No. So let me go to the next element. 3 is equal to target? No. I'll go to 5. Is 5 is equal to target? No. Is 8 is equal to target? No. Is 9 is equal to target? No. 15 is equal to target? Yes. Now what is the index of that 15? 0, 1, 2, 3, 4, 5, 6 and then 7. So we'll be returning 7 as the answer, sorry, 5 as the answer to the code. Let us do one thing. We'll just go with that online compiler and let us execute it. Okay, let's start with a vector of int array is equal to, let us see what is this array, right? Okay, 1 3 5 8 9 15 20 30. 1 3 5 8 9 15 20 30. So this is the array values. These are the array values. Now what is the target? Int target is equal to 15. Now for int I is equal to 0, for int I is equal to 0, I is less than n, I plus plus. Then if array of I is equal to target, C out I, that's it, C out I and L, then no need to return anything, right? We have given array and then the target. So let us run the code. Compilation n was not declared in the scope. So what is the n value? 7 elements, right? So the n value will be 8. Okay, let me run the code once again. Ni is capital here, sorry. Yes, the output expected as 5 and we got it as 5. But let me tell you how does we search in a binary search algorithm, right? So let us see. First thing, so in which company you are working? Bro, I am not been placed till now. I am in my 4-1 semester, right? So thanks for joining the live chat and this live session. Okay, let us see how can we go with the binary search, right? how can we go with the binary search? If you see, what if I, this is a sorted one. If you see, this is a sorted array. We need to keep that in mind. Now, let me take 0 plus 7 is 7 by 2. 2 threes are 6. So it will be 3. Now what I'll do, I'll just go to 3 and see whether the element at that position is equal to target or not. No, it is not equal to target. But this array of, let me take this as mid. Why? Because I'm adding this 0 nothing but low, and then this 7 nothing but high. Low plus high by 2 will be nothing but the mid, right? So if array of mid is lesser than the target, what I'll do is I'll just make the low pointer to the mid. Why? Why I'm doing like this? Because I surely know that the element which we are searching for is greater than this. So what I'll do is I will search in this subarray or in this range. So that's why I'll change low is equal to mid. So if array of mid is less than target, low is equal to mid. Now, else if, what if, right, 3 plus 7 by 2 is 5. However, we get an answer. But what if we are, our mid is here, hypothetically. If our mid is here, then I need to change the high to this mid, right? Why? Because if mid array of mid is lesser than target. If array of mid weights, right? So the target is greater than array of mid. So what I am doing is I am just changing low is equal to mid. Now if array of mid is greater than target, then I will change high is equal to mid. Now, what if it is equal to, right? So else the case is array of mid is equal to the target. That's why I just left it as else. So I'll just return mid. That's it. Let us see by the code. First, I'll start with int low L is equal to 0, high is equal to n minus 1, right? While let us see L is less than or is equal to H. Now, first thing, int mid is equal to L plus H by 2. If array of mid is lesser than target, then low is equal to mid. Else if array of mid is greater than target, then high is equal to mid. Else just return mid, right? Then we'll be break the loop, right? So yes, see out target not found if we didn't find the target. Let us run this. Low is not initialized. Okay, instead low and then high, right? High and then low. Okay, let me run the code. Yes, here low, high, sorry, again it was a mistake. Target not found. Okay, so if array of mid is not equal to target, then we will print it, right? We got 5 and then target not found. Mid was not declared. So let us just remove this, but let us see by using flag is equal to true, right? Bool flag is equal to false. So if the flag is false, then target not found. Let us change here 15 to 17. Now let me run this. I think it might give me a time limit. Yes. Let me tell you, I am saying that low is less than or equal to high. What I'll do is I'll just change it to high is equal to bit minus 1 and low is equal to bit plus 1. Right? Yes. Target not found. So let me tell you this right. This is the standard way of using binary search wherever you go. Low is less than or equal to high, and low is equal to mid plus 1 for some option, and high is equal to mid minus 1 uh, if the answer is on the left side, we'll use high is equal to mid minus 1. If the answer is on the right side, we'll be using low is equal to mid plus 1. Let us see. There are some things we need to make sure. Okay, let us make sure those things. Firstly, the array need to be sorted. The array has to be sorted. Now, you might ask me why. Why? Because I am having 1, 2, 5, 7, 9, 20, 30. I am saying that I need 20 as the target. Now, I am at 7. Let us think that we are at 7. Now, I am changing the load to here. Why? Because I am saying that the target will be after this. Why? Because 7 is lesser than target. So that's why the array has to be sorted so that we can change the low and also high. And then there are many things like binary search or answers, right? So we need to be make sure that we don't get the TLE while we executing this. So this is the main error in binary search. If you knew that this is the default or like a template code for binary search, then it will be easier for you. So you can take a screenshot or note down in your books, right? Okay, it's just 15 minutes we have started this live session. Let us see, right? So TLE is the first thing, and also we will not be getting any MLE, memory limit exceed error, right? So the TLE is the only thing which we need to be concerned about, right? We'll be solving some of the problems today, right? And remaining problems I'll be giving you for practice. Let us see what are those problems. First, let me take this binary search. Let us see. Given an array of integers nums, which is sorted in ascending order. Yes, and an integer target. Write a function to search target in nums if target exists. If the target exists, then return its index. Otherwise, return minus 1. You must write an algorithm with big of login. It's the same thing here. Bool flag is equal to okay. Let us just copy this code, but we need to change some things. Let us see. Int n is equal to nums dot size. And is there anything? No. Bool flag is equal to true. If it is not flag, or flag is equal to true, no. Let us return the mid here itself. Mid. If not, return minus 1. Return minus 1. Let us run this. Hope there will be no errors. Array of mid is less than target. So array is not uh, there in this right array. Let us replace that with nums everywhere. Select and replace everything. Let me run this again. Let me submit that. So yes, we have already solved this, and here, if you see, I have forgot to mention. Let me write the template code for binary search. Let me write it first. Where we will be starting with. First, we'll be having int n is the size, and L is nothing but low is equal to 0, and high is equal to n minus 1. While L is lesser than or equal to H. I am saying you this is the template code which I'll be using for your thoughts and also your process. You can select the code which you want to, right? So let me take the mid here. Int mid is equal to L plus H by 2, right? Now there is this case, right? If array of mid and all, so instead of low is equal to mid, I'll say low is equal to mid plus 1 and high is equal to mid minus 1. Let us see. If array of mid is lesser than the target, then low is equal to mid plus 1. Else if array of mid is greater than target, then high is equal to mid minus 1. High is equal to mid minus 1. Now else, that means we got the answer. So then return mid there itself. Right, so this is how we solve the binary search. But the first problem is an easier problem for today, right? Time taken is 1 minute 28 seconds, as we have already solved it in the online compiler, right? So if you are having any doubts, please let me know in the live chat, right? So it is not an easy one, so there will be also harder problems as we go to trees, graphs, dp and all. But this is for me when you have started with arrays and then hash map and then sliding window and then prefix sum. So these are the 4 days which we have covered in the previous live sessions. First we started with arrays, and then we went to hash maps, and then we went to sliding window and then prefix sum. So today we are discussing about binary search. So if you are having any doubts, please let me know in the live chat, and we'll be starting this again in just 2 minutes. But before that, let us see that I got 10 subscribers, right? So for today, the goal I had set is 850 subscribers. I don't know whether I can reach or not, but there will be live sessions every day, but for 30 days. And I don't say that, and I don't overwhelm you or over promise you that you will be getting this, all the DSA problems, all you will be mastered. But I can make sure that you will be understanding every concept, but you can even master it if you give more hours. When I've started this DSA, I used to give like 2 to 3 hours when it was starting. Like for one problem, I used to give 2 to 3 hours. So I don't say that in a over promising promises, right? So you will be getting DSA in just 1 month. No, you need to start practicing it. At least takes 3 months. So I'm just explaining you the concepts and also some problems so that you can solve by yourself. Okay, let us see the second problem in today's binary search, right? So find first and last position of element in sorted array. Okay, find find first and last position in the sorted array. First and last position of an element in a sorted array. Let us see how can we solve this. But before that, let me explain you what it means. Given an array of integers nums sorted in non-decreasing order, that means increasing order, however, it is sorted, but it's not strictly increasing. Why? Because we can also have duplicates. Find the starting and ending position of a given target value. If target is not found in the array, return -1 comma -1. You must write an algorithm with big O of log n. Let us see. So here I'll be going with the brute force, which takes big O of n, however, and then we will go to the binary search. Let us see. First, as they asked for first index, I'll go for first index. First and last position is 34. Let me give you the problem link in the live chat. Wait a second, right? So yes, I have pinned the uh, comment and also this link of the problem. Yes, let us go. Right. So let us take 5778810. Target is equal to 8. 577. This is 34. 34 find first and 34 find first and last position of an element in sorted array, right? Let us take the example 5778810. 5778810. And what is the target given to us? This is the nums are given to us, and the target or element, right? It is the element. Yes, it is the target. However, target is equal to 8. Now, if you see by seeing it clearly, we can say that 0, 1, 2, 3, 4, 5. The first index which we got, wait a second, first index which we got is at 3, so it will be at 3. And the second or the last index, it is not the second, however, it is first and last. So last index is equal to 4, right? So this will be written, however, but I'll tell you that I'll be iterating through this array for 2 times. First, go with this, it is not equal to target, no need. Is it equal to target? No need. Is it equal to target? No. Is it equal to target? Yes. So the first index I got is 3. Now I'll go from back, then I'll get the last index. So here it is not equal to target. Here is it equal to target? Yes. So the last index, as I went from the last, I got 4. But what is the time is it taking? But let us write the algorithm and then discuss about the time. First, for I is equal to 0, I is less than n, and then I plus plus. If array of no nums of I is equal to target, then first index is equal to I, then break there itself. Now for I is equal to n minus 1, for I is equal to n minus 1, and I is greater than or is equal to 0, I minus minus. If nums of I is equal to target, then the last index, right? The last index is equal to I, then break here itself. Now what we need to initialize the first index and last index with. So the first index will be -1 and the last index will also be -1. Now if target is not found in the array, return -1 comma -1. That's it, right? So we'll be returning first index, first index comma last index, right? So that's how we solve this problem. But let us see what's the time complexity for this. So if you see, I am going for the first index. What if there is only one target here and there is this nums, right? So I'll go here, big O of n by 2, big O of n by 2 here. I'll go to this big O of n by 2. So both big O of n by 2, big O of n by 2 is nothing but big O of n. So the time complexity taken here is big O of n. Are we using any extra space? No. So big O of 1 itself. Let us write the code. Int n is equal to nums dot size first index is equal to -1, last index is equal to -1 for int I is equal to 0. I'm participating a coding competition in my college which is based on DSA. Okay, bro, all the best for participating. I hope you do your best in this coding competition, right? So I'll be you can ask me if you are having any doubts, right? But even it is only for first years. Okay, so I think you are from first year, right? So nums of I is equal to target, then the questions are very hard. So I okay, you are participating like sliding window. Okay, the sliding window I have already created a live session on that, sorting like that. Okay, let me know the question, bro, so that I can explain you the what it is about, right? So let me know the question in the comments, right? So that I can explain you. But no one even know that concepts. Okay, so every time in every colleges, right, it will be starting in second year the data structures, right? So I think in second year I got the data structures as 2-1 semester, and then in 2-2 I got this algorithms. Yes, the data structures is another subject, and algorithm is also another subject. Yes, merging two sorted arrays. It is most asked problem. Merging two sorted arrays. I'll tell you how, bro. Wait a second. But let us solve this first and last index, last position. I have already solved it, however. But let us see. First and last position. First, nums of I is equal to target. First index is equal to I, and then break there itself. Now, I'll do the same thing here, but I is equal to n minus 1, I is greater than or equal to 0, and then I minus. If nums of I is equal to target, last index is equal to I. Return first index, wait a second, return first index comma last index. Let me run it, and then let us go with the merge sorted array. Let me run this. It will take big of n, however, right? I need to optimize it. Let us see. You are given two integer arrays nums1 and nums2 sorted in non-decreasing order, and two integers m and n representing the number of elements in nums1 and nums2. Merge nums1 and nums2 into a single array sorted in non-decreasing order. The final sorted array should not be returned by the function, but okay, instead be stored inside the array nums1. To accommodate this, nums1 has a length of m plus n. Okay, where the first m elements denote the elements that should be merged, and the last n elements are set to 0 and should be ignored. Okay, nums2 has a length of n. Let us see here. If you see here, I got 1, here I got 2, now here I got 2, and then what I think is the 2 should be coming here, and then I need to get this 3. But how can I get that? Right, 1 2 2 and then 3. Then this 3 will be going here, and then we'll be having a, okay, let's do a brute force on this. However, we'll be going with the optimized one. So around Aharon, right? So your name is Aharon, right? So sorry if I pronounce it wrongly. Merge two sorted arrays. They said that you won't be getting uh, a new array. We should not be returning a new array. Instead, we need to change nums1. Let us see. Nums1 is equal to 1 comma 2 comma 3 0 comma 0 comma 0, and nums2 is equal to 3 comma 5 comma 6. Now what I'll do is I'll start with if you see nums2 is of size m is equal to 3 and n is equal to 3, m and n, right? So it is of size n, and it is wait a second, m and n. Okay, m is equal to 3. Yes, this is 3. So what I'll do is I'll start with index. If you see 0 1 2 3 from this, so what I'll do, I'll just change it. I'll tell you how. Nums1 is equal to 1 comma 2 comma 3. Then this 3 will be initialized here. This 5, if you see, so I think, sorry, it is 256. Sorry, it is 256. So 2 will be initialized here, and then 5 will be initialized here, and then 6 will be initialized here. Instead of 0, I am placing 2, and then I am placing 5, and then I am placing 6. Now just sort it. Nums1, sort the nums1. I'll get 1 comma 1 comma 2 comma 2 comma 3 comma 5 comma 6. So this will be not written, but however it has changed, but it is not the one which will be of optimized. It is just a brute force one. If you see, I'm going with big O of n. Let me write the algorithm here first. For int I is equal to m, I is less than I is less than m plus n. Okay, m plus n and I plus plus. Now nums1 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 of I is equal to nums2 of j and j plus plus. Here j is starting with 0. Now after that, let me sort the nums1. Sort nums1 dot begin, and then nums2 dot end, right? This is just a brute force. However, it is not the last one. So this is having a time complexity of big O of n, right? Here it is having big O of n. Why? Because it is n, right? And nums2 is of size n. Now here the sorting will take big O of n log n plus m log m plus n, m plus n log m plus n. So let us write this code first. Int j is equal to 0 for int I is equal to m, I is less than m plus n, I plus plus. Now nums1 of I is equal to nums2 of j. Then sort nums1 dot begin and nums2 dot end. Let us see. I have run the code. Sorry, j plus plus. I need to increment. Let us see. I is equal to m. Okay. 3. I is less than m plus n. Okay. There might be a case here. I is less than m plus. Okay, 3 plus 3 is 6. 0, 1, 2, 3. So I am starting at okay, 3, 4, and then 5. But I don't know why I am getting a runtime error. Okay. C out I and L. Let us see how many times it would be running, right? Okay. 3, 4, 5 is less than m plus n. Okay. But it didn't went to okay. Nums2 of j. So it has applied to 0. Okay, okay, right. So it has applied to 0 nums2 of j. 0 is nums2 of 0 is applied to nums1 of m, right? No, there might be an error here. See out I nums2 of j. Okay, let us write it like this. J is less than nums2 dot size. Instead, let us write nums1 dot size here. Nums1 dot size. If j is less than nums2 dot size, then only it will be executed. Okay. No, we got the error again. 0, 1, 2, 3. Okay, we got 0, 1, 2, 3, 4, and then 5. I is equal to m. I is equal to m. M is equal to 3. That is, we are merging R. So I think there should not be like this. We should not change, I think. No error in loop. Yes, there is no error in the loop, but sorting this nums1 dot begin and okay. So nums1 dot begin and nums1 dot end, right? So that's what the error I made. That's a blunder for me. So just a spelling mistake. I have placed nums2 instead of nums1. Let me submit it. Right. Now, let us see how can we use a two-pointer approach on this. It is not a better approach. It is just a brute force approach, right? Let us see how can we solve this. If you are having any ideas of two pointers on this, let me know in the live chat. Let me know in the live chat, right? So yes, merge two sorted arrays. We are solving this merge two sorted arrays, right? Okay. Okay, let us see how can we solve this with a two-pointer approach. 1, 2, 3, 0, comma 0, comma 0, 2, 5, 6. This is nums1 and nums2 is equal to 2, 5 and then 6. Okay, let us start with uh, let us start with starting with at the end. Let me tell you why, right? Okay. Okay, let us see how can we solve this by using a two-pointer approach, right? Let me tell you that I will take a pointer here and then a pointer here. So, uh, okay, and if I take a pointer like that, let us let us initialize this. Let's initialize this first. This is 3, right? So I got a 3, nothing but this is m minus 1. The index is m minus 1. Now, first, let me tell you that n1 mint and then what about this pointer? right? So let me write it. This is my right pointer, and this will be n2 index. Let me write it like this: n2 index, and this is my n1 index. This is quite not an easy problem. Let us see what is the, sorry, no, description. What is the acceptance rate? It is just 53%. It is like a medium problem. However, let us see n1 index, and this is our right. Now n1 index is at m minus 1. N1 index is at m minus 1. Excuse me. N2 index is at n minus 1, and the right pointer is at, what is this? This is at m plus n minus 1. So let me write it. Right is equal to m plus n minus 1. Now I'll iterate while, wait a second, iterate while n2 index is non-negative, right? So let me tell you, let me tell you, while this n2 index is greater than or equal to 0, while this n2 index is greater than or equal to 0, I'll compare the elements and then merge. If n1 index is greater than, n1 index is greater than n2, sorry, nums2 of nums, wait a second, right? First thing, I will be comparing the elements, right? So I will be comparing the elements. First, nums1, nums1 of n1 index, if it is greater than nums2 of n2 index. So I'm just comparing this 3 with this 6. What will be happened here? I'll tell you what it will happen here. Then place, if it is greater, then place nums1 uh, nums1 of n1 index at, wait a second, nums1 is if it is greater, nums1 of n1 index is placed, this is placed at nums1 of right. At nums1 of right, we will place nums1 of n1 index. I'll tell you why. Right now, if n1, let me write it over here. If n1 index is greater than or equal to 0, and nums1 of n1 index, nums1 of n1 index is greater than nums2 of n2 index, right? So if this nums1 of n1 index, if this is greater than this one, right? If this is greater than this one, then what we need to do? This should be placed at the right. So that's what I wrote. Nums1 of right is equal to nums1 of n1 index, right? Then n1 index is decremented by 1, right? I think you are clear for this. I think you are clear till now. Now let us see another else condition, right? Let us see an else condition. First, if this is the thing that n1 index, the number at n1 index is greater, then we'll place this at the right pointer. Now if this is not the case, then what we need to do? I got 3 and 6. I got 3 and 6. What I need to do? Nums1 of right Here I will place nums2 of n2 index, right? So if here itself, see here itself, if this is the case, nums1 of n1 index is lesser than nums2 of n2 index, I will place this at this position, at the right position. So nums1 of right is equal to nums2 of n2 index. Then mid pointer which we have placed at here n1 index, right? N1 index, right? If you see, when we are placing this is changed, so we'll be decrementing it. Now we are placing this, so we'll be decrementing n2 index. So n2 index minus is equal to 1. Now move the pointer, move the right pointer left every time. So the right pointer will be decremented by 1 every time, and then that's the end of the loop, right? So let us see how can we code this up. Let me write the code here. First let me initialize everything. First I got n1 index and then n2 index, and then the n2 index, right? And I got the right pointer, right? Sorry, that's the disturbance from outside. Let us see. First I have initialized the n1 index and then n2 index, right? N1 index is equal to m minus 1, n1 index is equal to n1 index m minus 1, n2 index is equal to n minus 1, right is equal to m plus n minus 1 minus 1. Okay, now we'll write a loop while n2 index is greater than or equal to 0. While n2 index is greater than or equal to 0, we'll write a loop where wait a second, if in this while loop, first if n1 index is greater than or equal to 0, if n1 index is greater than or equal to 0 and nums1 of n1 index, this is greater than nums2 of n2 index, then what we need to do here, nums1 of right nums1 of right is equal to nums1 of n1 index, right? Then n1 index minus is equal to 1. Then else if this is not the case, then we will say nums1 of right will be changed to nums2 of n2 index, right? Then n2 index minus is equal to 1, then right minus is equal to 1. That's it. Let's run the code, hope that it gets accepted. Yes, it got accepted. Let me submit the code. So I think, brother, your doubt has been cleared. If you are having any doubts, please let me know in the live chat. I'm also giving my linkedin.com/in/rsai You can message me there itself, right? So now let's come to the problems again. Let's come to our problem again. First and last position, right? We were solving this and we got a doubt of merged to sorted arrays. So let us start with it. Right? First and last positions. Now let me write a binary search algorithm. algorithm for this. Now, a vector in such range. So what we'll do, vector of int, I'll initialize result vector with size 2 and -1 uh, as the first and last position, right, of element. So I have initialized it. Now int n is equal to nums dot size, and then int left is equal to, I'll search for binary search left nums comma 0 comma n minus 1 comma target. Then the same thing here, left, and then here right. So binary search right here, and if left is less than or equal to right, then result of 0 is equal to left and result of 1 is equal to right. Return result. Now let me write binary search left and also binary search right. So that's the same thing of binary search, just the template code has changed something. Let me tell you. First, int binary search bs left with vector of int, let me name it as array, and then I got low and then high and then target. Int low, int high, and then int target. Then in this I'll start with the same code, low is less than or equal to high. So I need the pointer which is the lowest, right? So int mid is equal to low, high minus low, high minus low. So low plus high minus low by 2. So that we don't get any decimal values like that, so that we don't get any error or any runtime error. So that's why we'll be using low plus high minus low by 2. If array of mid is less than target, then low is equal to mid plus 1. If not, else high is equal to mid minus 1, then return low at the end. Let us copy the same thing for binary search right. Vector int of array, int low, int high, and then int target. While low is less than or equal to high, int mid is equal to low plus high minus low by 2. Then if array of mid is less than or equal to target, then we will go for the right the right one. So the last one which we will get, we will be returning that. Here, instead of returning low, we'll return high. So let me run the code. Int high is equal to high by 2. Okay. The same error here. It got accepted. Let me submit the code. Right. So yes, it's already 9:09. Right. Let me take a 6 minutes of break. So Aharon Cosetti. So let me know if you have understood the merging to sorted arrays problem. Oh, find first and last index. Yes, we have solved that one. And if you have any doubts, please let me know. Now we'll be going to solve the third problem. Search a 2D matrix, right? So yes, let's go with such a 2D matrix. What does it mean? Let us see. So we are given with m by n integer matrix with the following two with the following two properties, right? Each row is sorted in non-decreasing order. That means it will be increasing, right? 1, 3, 5, 7, 10, 11, 16, 20, 23, 30, 24, 60. They use this non-decreasing order because there might be a chances of same element. So if there is same element, you can't say increasing, right? So if I have 1, 3, 5, 5, and then 7, you can't say that increasing, strictly increasing. They might be a non-decreasing. That's why they use this term non-decreasing. The first integer of each row is greater than the last integer of the previous row. Okay, it is nothing but 1, 3, 5, 7, and 10, 11, 16, 20. So 1, 3, 5, 7, 10, 11, 16, 20. Let me write such a 2D matrix 74. Search a 2D matrix 1, 3, 5, 7, 10, 11, 16, 20. 1, 3, 5, 7, 10, 11, 16, 20, and then 23, 30, 34, 60. 23, 30, 34, 60. Now, this is the matrix given to us. Let us see what is the target given to us. So this is a 2D matrix, of course. Now, let us see what is the target. Target is equal to 3. Yes. So the target is equal to 3. Now we can go with a linear search, right? So linear search, right? 1 3 5 7 and then 10 11 16 20. If it is present, the target is present, then we need to return true. If not, we'll return false. So instead of any binary search algorithm, let's go with for I is equal to 0 to number of rows, for j is equal to 0 to number of columns, if matrix of matrix of ij is equal to target, then return true. That's it. If not, we will return false at the end. Let us do the code for this. It will take big of m into n, right? It will definitely take big of m by n, right? For wait, I need to know number of rows. Int rows are equal to matrix dot size. Columns is equal to matrix of 0 dot size. For int I is equal to 0, I is less than number of rows and I plus plus. For int j is equal to 0, j is less than columns, j plus plus. So if matrix of I j ij, if it is equal to target, return true. If not, return false at the end. Let me run the code. Yes, let me submit it. It might get big of m into n, but I know we don't know, like, okay, it got accepted. But let me optimize it. However, how can we use a binary search algorithm on this? Let me take if if you see uh, if you see what I think. Let me start from here. Let me start from here. The row is 0, row is 0, and let me start with this. Column is equal to columns minus 1, right? Then if the current one is this element 7. Now if the current element is equal to target, will return true. If not, if the target is uh, if the target is greater than the current element, then we need to go here, right? Now if the target is lesser, then we need to go to here. Let me tell you, if target is greater than current, then we need to increment the row, right? So after this, I'll get this, right? After this, I will get the next element which is greater than that element. Now if I want an element which is lesser than that, so I need to go to the previous column minus minus, right? So while row is lesser than rows and column is greater than minus 1, current is equal to matrix of row and column. Wait a second. Row and column. Now if current is equal to target, will return true. If current is equal to target, return true there itself. If not, go with this. If target is greater than current, row plus plus, and else column minus minus. Now int, we know about the rows and columns, but row is equal to 0 and column is equal to columns minus 1. At the last, return false. We'll do the same thing, right? So int row is equal to 0, column is equal to columns minus 1, while row is lesser than rows and column is greater than minus 1, nothing but it is at least 0. int current is equal to matrix of row and then column. Now if current is equal to target, if current is equal to target, return true. If target is greater than current, we need to go to the next row, else column minus minus. That's it. So we are taking something like big O of log m by m into n time complexity, right? So this will take big O of m into log m into n, log m into n time complexity. And are we using any extra space? No. So it will be taking big O of n space complexity. Yes. So this is about the fourth problem. I think this is the wait a second. First we have solved the binary search and then find first and last position in a first and last position of an element in an array. So that's the second problem, and this is the third problem. Now let us see the fourth problem, and I'll give you the four problems as a practice, right? Let us see. Find minimum in rotated sorted array. What does it mean, right? Find minimum in rotated sorted array. Let me tell you uh, about the problem. Suppose an array of length n sorted in ascending order is rotated between 1 and n times. Okay. For example, the array nums is equal to 0, 1, 2, 4, 5, 6, 7 might become 4, 5, 6, 7, 0, 1, 2 if it was rotated 4 times. If you see 7 has become 1, I'll tell you what it made it. Let me tell you. Notice that rotating an array one time results in array of n minus 1. That's what that gave you. So the last element will become the first element. That's it, the rotating means. Given the sorted array nums of unique elements, return the minimum element of this array. It is not something like a sorted array, but you must write an algorithm that runs in big of n log n time. Let me tell you, if I sort that, I'll just miss the index, right? If I go by the minimum, I'll get a linear search. Wait a second. I'll go with int. What what if I was having 3 4 5 1 2, right? 3 4 5 1 2. If you see, let me take the minimum is equal to infinite. Now 3, is it lesser than minimum? Yes. So let me take it as 3. Now let me go to 4. Is 4 is lesser than minimum? No. Is 5 is lesser than minimum? No. Is 1 is lesser than minimum? Yes. So 1 is our answer. And then is 2 is less than minimum? No. So I'll return 1. But what time is it taking? But before that, let me go with the algorithm. Mini is equal to int max for I is equal to 0, I is less than n. If nums of I is lesser than minimum, then minimum is equal to nums of I. At the last of this loop, return minimum. Let me write the code for this. So int n is equal to nums dot size, int n is equal to nums dot size, and then mini is equal to int max for int I is equal to, wait a second, for int I is equal to 0, I is less than n, I plus plus. If nums of I is lesser than mini, mini is equal to nums of I, right? At the last return mini. Let me submit it, but can we get it in a lesser time? I'll tell you. What if I sort it? Sort the array and return the first number, but for sorting itself will take big of n log n time complexity. But let us do that. However, return nums of 0, the first element is returned here. So first sort nums dot begin comma nums dot end. It will take big of n log n time complexity. If you have any doubts regarding this, please let me know in the live chat. Okay, it got accepted, however, but we are taking big of n log n. It is not even optimized more. We can optimize it much. Let me tell you how. First, let us do a binary search on this so that we get to know. Let me tell you how can we uh, use this binary search. So in the binary search algorithm, we'll be having low and also high. We'll initialize the low to 0 and then high to n minus 1. Now, while low is lesser than high, what I'll do, mid is equal to low, mid is equal to low plus high minus low by 2. So if the array of mid is greater than array of high, if the mid element is greater than array of high, right? So what does it mean? Let me take the same example, 3 4 5 1 2, 3 4 5 1 2. So the array of mid is greater than array of high. Here it is mid, here it is high, and here it is low. So array of mid is greater than array of high. Now what I need to tell you is I'll be having the element between these. Why? Because if I was having uh, with like 1 2 3 4 5 6 and then 7. Now this is my mid. Let me take uh, let me take this like array of mid here is lesser than array of high. What does it mean? It will be having previously. Why? Because this is increasing. After this mid it is increasing, but I need the number which is the least number. So what I'll do, high is equal to mid minus 1. Now what I need to here I need to do here, I need to do low is equal to mid plus 1 here. So let me change this, right? So okay, now let us do the same thing here. As I said, array of mid is greater than array of high. Change low is equal to mid plus 1. So low is equal to mid plus 1. If not, else high is equal to mid. Low is lesser than high, right? So here we are not using less than or equal to, so we can change it to only mid. High is equal to mid. There might be a possibility that we got it like, why we, you might ask me why we are not taking like high is equal to mid minus 1. Let us initialize this like 6 7 1 2 and then 3. Now this mid, array of mid, is lesser than array of high. This is my low. So array of mid is lesser than array of high. If I made high is equal to mid minus 1, then the high will be here, but here I doesn't have the least value. Here is our least value. So there might be a possibility that we might miss our target value, the minimum value. So that's why high is just changed to mid, and at the last return array of low. I'll get the array of low, which will be storing the minimum value in the minimum value of the array. Let us take this. Let us take the algorithm and let me write the code. So as this is the last problem for this today's live session, I'll be giving you the other four problems as practice, and if you have any doubts, please let me know in the live chat. Right, so let's start. Int answer is equal to binary search with nums and low is 0 and minus 1 is high, and then do we have anything else? I think no. N minus 1 and high. Yes, that's it. 0 1 and n minus 1 as high, 0 as low. Now return answer. That's it. But we doesn't have n, right? So int n is equal to nums dot size. Now int bs, vector of int array, and int low, int high. While low is lesser than high, first let's calculate the mid. Int mid is equal to low plus high minus low, low by 2. If array of mid is greater than array of high, I'll just change low is equal to mid plus 1, else high is equal to mid. At the last, return array of low. Let us run this code. Has got accepted. So I'll be giving you this four problems as the practice. Search in rotated sorted array, find peak element, cocoa eating bananas. This is like a hard problem for me. When I have solved it, I spent like 3 hours on this problem itself. So capacity to ship packages within D days. This is binary search on answers. If you have any doubts, please let me know in the live chat. We'll be ending this in just 5 minutes. Let me know in the live chat if you are having any doubts. Let me know in the live chat. Right, binary search, binary search. So the binary search on answers is just a simple thing. If you don't have a clear precise idea about the answer, but you know the range between where the answer can be. Excuse me. Then you can just take uh, this binary search and execute on make that execute on answers, right? Okay, I hope you understood this today's live session. So let me know in the live chat if you are having any doubts. You can ask me in the LinkedIn. So I have given the profile link in the live chat, right? So yes. Yes, if you are having any doubts regarding this DSA, let me know, right? And I have also given the DSA roadmap, DSA roadmap in I have given it in, I think, Instagram page, right? You can also follow me in Insta underscore R underscore S underscore S underscore 11. Yes, that's my LinkedIn profile and also Instagram. Internal error cult. Yes, we'll be ending this. Okay. So let us see, can we hit, yeah, at 50 subscribers before we end this session? And we just need 39 more subscribers. So yes, let us see. Please let me know in the live chat, right? So at 9:40 sharp, at 9:40, we'll be ending this live session, right? In just 2 minutes or like 1 minute. So we'll be ending this live stream in just few seconds, right? So yes, we'll be ending this in just few seconds, right? Okay.